Welcome everybody. Today I am going to explain you how we can implement full subtractor. So in case of full subtractor, we know that there are two output. First one is difference, second one is borrow. So this is K-map for difference and this is K-map for borrow. Then from this K-map, these two expressions are obtained. One is for difference and second one is for borrow. So expression for difference is D is equal to A XOR B XOR B in, and expression for output borrow is B out equal to A prime into B in plus B into B in plus A prime into B. So here first of all let's try to draw logic diagram. So here let me show the inputs. So in this case inputs required are A. Now observe these two expressions. You will come to know that in order to implement full subtractor, we also required A prime. Okay. So let's assume that this particular line corresponds to A. Then here we will take NOT gate. So I can say that this particular line will correspond to A prime. Then the next input is B. Whether we required B prime? No. Then next input is B in. Whether we required B in prime? No. Then let's try to implement this D. So in order to implement this D output, we require XOR operation between A, B and B in. So see, so here let's assume that we have two input gate. Okay, so we have two input gate. So first of all we want XOR operation between A and B. So let's show that XOR operation. Then we want XOR operation with B in also. So take one connection from B in, take here XOR operation, and then here I will get final output D, which is nothing but A XOR B XOR B in. Then which is second output? B out. In order to implement this B out, we required AND operation between A prime and B in. So where is A prime? So this line corresponds to A prime. So let's take one connection from A prime into B in, A prime into B in, perform AND operation. So here output of this AND gate will be A prime into B in. Then which is the next term that we want? B into B in. So B into B in. So AND operation. So here I can say that this is B into B in. Okay, then here we should perform OR operation between these two outputs. Then which is the last term that we want here? We want A prime B. We want A prime. So this is A prime. Then A prime into B. So this is B. So take AND operation. So here I will get A prime into B, and then here again we should perform OR operation so that we will get final output, that is B out. So I can say that this is logic diagram for full subtractor. Now let's see how we can implement this full subtractor.
Now let's see how we can perform simulation of this particular circuit. So in order to perform simulation of this circuit, I am going to use Smart Logic Simulator app. So first of all, open app. So I have already opened the app. After opening app, you will get one window which is somewhat like this. Then you should click on your circuit. Then click on create new. Then click on project. So first of all, see, in order to implement this circuit, we require three inputs, that is A, then B and B in. So let's take three input. So in order to add these inputs, first of all, you should click on this pencil icon. After that, on bottom side, you will get plus sign, click on it. Then here you should select toggle button. So how many toggle button? Three toggle button. So each toggle button will correspond to one input. So see, one toggle button is added. second one is added, and third toggle button is added. So I have added 3 toggle buttons. So this is first toggle button, second, and this is third one. Now here we can rename, we can give a proper label to each and every toggle button. So let's start with first toggle button. So I told you that each toggle button correspond to one input. So first toggle button will correspond to input A. Second toggle button will correspond to input B. Third toggle button will correspond to input B in. Then let's see our logic diagram again. So see, in this logic diagram we also required A prime. So in order to obtain A prime we should add NOT gate. So let's add now NOT gate. So again click on plus sign, then select NOT gate added. Okay, so just put this NOT gate at proper position. Now what we want A prime. So that's why what should be the input to this NOT gate? Yes, it should be A. So in order to do this connection you should click on this particular symbol. So click on it, then click here and click on input terminal of NOT gate. So see, connection is established. Then let's move ahead. There are two outputs in full subtractor. First one is D and second one is B out. So how D is obtained? So in order to obtain D, actually we should perform XOR operation between A, B and B in. So in order to implement this particular expression, we will require 2 XOR gate. So let's add 2 XOR gate here. So again I should click on this pencil icon, then plus sign, then add 2 XOR gate. First XOR gate added, second XOR gate added. Okay, now let's keep this XOR gate at proper position. So suppose here I will put first XOR gate and I will put second XOR gate somewhere here. Okay, now what should be the input to first XOR gate? Let's make the connection. So for that I should click here. Okay, then now I will click on terminal which is corresponding to A and one input terminal of XOR gate. Then I will click on this terminal which is corresponding to B and other input of XOR gate. So first XOR gate, connection of first XOR gate are over. Now let's move to second XOR gate. So we want which operation? A XOR B in. Okay, so see, I will connect output of this XOR gate to the input of next XOR gate, and which input is remaining? B in. So this B in should be connected to other input of XOR gate. So what will be the output of this XOR gate? So I can say that on output pin of this second XOR gate I will get our required difference. So this is our final output. So here now we should add one light bulb. So take one light bulb and this light bulb will correspond to difference. Okay, so accordingly I will give one label to this light bulb. Now let's make connection. So for that again click on this symbol, click on output terminal of XOR gate and this terminal which is corresponding to this light bulb. So see, one output is ready. Now let's move for second output. So which is second output? B out. So in order to obtain this B out, so see, actually we required 3 AND gate. So let's add 3 AND gate in our circuit. So in order to add 3 AND gate, again we should click on this pencil icon, then plus sign. How many AND gate? 3 AND gate. So where is AND gate? Yes, one AND gate added, second AND gate added, and third AND gate added. So we have added 3 AND gates to our circuit. Now let's keep this 3 AND gate at some proper position. Suppose this is first AND gate, this is second AND gate, and this is third AND gate. Now let's make connection for first AND gate. So first AND gate is going to produce which term? A prime into B in. So A prime into B in. So let's make this connection. So for that again click on this symbol. So which is A prime? So output of this NOT gate will give me A prime. Okay, so click on output terminal of this NOT gate and click on one input terminal of first AND gate. A prime into B in. So where is B in? So this is B in. So click on terminal which is corresponding to this B in and connect this B in to second input of AND gate. So I will get first product term, that is A prime into B in, which is second product term, B into B in. So now let's try to make this connection, B into B in. So where is B? Yes, here we have B connected to first input of second AND gate. Then this is B in connected to second input of second AND gate. Okay, so second product term is over. Then which is third product term? See, it is A prime B. A prime B. So let's try to make connection A prime. So where is A prime? So we know that output of this NOT gate will give me A prime. So connect output of this NOT gate will give me A prime. So connect this terminal to first input of third AND gate and second input. So which is term that we want? A prime into B. So we have connected A prime. Now we want B. So where is B? So this is B. So connect this B to other input of AND gate. So connections of all AND gate are over. Then what is next step? We required here 2 OR gate. Okay, here we require 2 OR gate, and this 2 OR gate, they should perform OR operation between this 3 product term. Very simple. So now let's add 3 OR gate. So again click on this pencil icon, plus sign, 1 OR gate, second OR gate. Okay, so 2 OR gate are added. So let's put this 2 OR gate at proper position, first OR gate, second OR gate. Now let's make connection. So again click on this symbol. So output of first AND gate should be given to input of first OR gate. Then output of this second AND gate should be given to second input of first OR gate. So connection of first OR gate are over. Then let's make connection for second OR gate. So what should be the input to this second OR gate? Yes, output of this first OR gate should be connected as input to second OR gate. Output of this third AND gate should be connected to second input of second OR gate. And output of this second OR gate will give me our final output, that is B out, that is borrow. So here again we will require one light bulb. So let's add one light bulb here. Light bulb added. Okay, now this light bulb will correspond to borrow. So accordingly we will give label here B out, save it. Let's make connection, connect this terminal to light bulb. So this is our final circuit diagram. Now after making whole circuit diagram, next step is we should verify whether our circuit is correct or not. So how we can verify our circuit? By using truth table, of given circuit. So already you are knowing truth table of full subtractor. So let's try to verify here. So here all inputs are 0. So if all inputs are 0, then borrow and difference will be 0 0. Okay, now let's make change in the input. So 0 0 1. Okay, so 0 0 1. So what truth table of full subtractor says? If inputs to full subtractor are 0 0 1, then difference and borrow both will be 1 1. So yes, we are getting here. Then let's try for next case 0 1 0. So see 0 1 0. This is 0, A is 0 1 0. So 0 1 0. So again same, both output should be 1 1. Now let's try for next input combination, that is 0 1 1. So 0 1 1. So 0 1 1, what it says? So in case of full subtractor, if inputs are 0 1 1, then see difference will be 0. Okay, and borrow will be 1. Then let's try for next input combination, that is 1 0 0. So 1 0 0. So difference will be 1 and no borrow. Then next is 1 0 1 1 0 1. So 1 minus 0 minus 1. So here difference as well as borrow both will be 0 0. Yes, it is correct. Then next is 1 1 0. So here again both outputs will be 0 0. And last case is 1 1 1. All inputs are 1 1 1. A is 1, B is 1, and B in is also 1. So in that case, see what is output? Both outputs are 1, means borrow is 1 as well as difference is 1. So in this way you can verify truth table of full subtractor easily with the help of this circuit. So this circuit is giving correct output as per truth table of full subtractor. So we can say that whatever circuit we have developed is correct.